All right, guys. When you go to the eye doctor, they put drops in your eyeballs that do what to your pupils? Dilate them. So it changes the shape of your pupils. When you are on medication or illegal substances, what do the police officers look for in your pupils? Dilation. So that this is something that we know about in our real life without. Now we're just going to apply it and put some mathematics to it. So a dilation has a center of dilation. We are going to just be dealing with a center of dilation of the origin. So where this big C happens here will usually be an O for origin. And a scale factor. So scale factor you can think of as a multiple or a multiplier. Let's try IER. So your scale factor is like a multiplier. You're going to multiply your original figure by your scale factor to either get a bigger one or a smaller one. So translations were, we use what letter to represent translation?
T.
T. And what kind of T?
A big T.
Capital T. What kind of letter do we use to represent reflection?
R. Big R.
R. And what kind of R?
Big one.
Big R. Transformation, big T. Reflection, big R. What about rotation?
Little R.
Little r. And now here we are with another letter representing dilation, big D. So you are in enlargement, so let's circle that. You guys are going to have to identify enlargement and also circle reduction. And it's important to know that we preserve angles and we create similar shapes. Just like it was important to know a reflection preserves distance. Same with dilation. You have your angles end up being the same. Your shape is going to be similar to the original shape. All right, and Grant, go ahead and pull reduction so we can write that definition down. So a reduction is when your scale factor n is between 0 and 1. It's like 1/2 would be a reduction. So if I'm starting at my original size and I have a reduction of 1/2, then I am shrinking, getting smaller. Okay, and Jesse? Oh no, wait, I'm sorry. Justin, in every other row. Go ahead and pull enlargement out, and so we can write that on our paper. So you guys, if reduction is between 0 and 1, what do you think enlargement scale factor is?
Bigger than 1.
Bigger than 1. So enlargement is when your scale factor is greater than 1. What? Merv, what if your scale factor is 1?
Then it's the same.
Merv. Huh? So a reduction is when your scale factor is between 0 and 1. Enlargement is when your scale factor is bigger than 1. What if it's equal to 1? Yeah, it's the same shape. If you're multiplying the side length 5 by 1, you're going to get a side length of 5. It's the same. All right, Kai, can you read example 1 for us? And remember that big D means dilation.
Is dilation and J equal to J prime, K prime, L prime.
So we got JKLM is the original, and J prime, K prime, L prime, M prime is the new one. Okay, is that an enlargement or a reduction? So if we start with the black and end with the blue, we are a reduction. And we need to find a scale factor. So Jack, so look at our side length for just the big one. Are there any side lengths that line up with one of the grid lines? That doesn't go diagonally. Is there any side lengths that match up with the grid lines? That doesn't go diagonally. That we can use the grid lines to find the distance. So you want your options? KL matches up with the grid lines, so we don't have to use the distance formula to find the length. Thank goodness, right? So what is the length of KL? 4. Count the boxes. So our original amount was 4. What do I multiply 4 by to get? And then Dylan, what is the side length of our new K prime L prime? Is it? Count the boxes. Count the boxes on your paper. You count them on mine. Whatever. Well, look. I need it to be definitive. Is it 2 or is it not 2? 1, 2. Okay. We gotta have confidence in our. So what do I multiply 4 by to get 2?
7.5. It's close.
1/2.
Sam? Yeah, 0.5. So our scale factor is 0.5. Just so that you guys can remember, the scale factor you can calculate, and you definitely want to write this down. It is the new over the old. The new shape over the old shape. Okay. Go back. All right. Now we're back. Damien, go ahead and read example 2 for us. Remember, what does the big D stand for? Dilation, and then what's this little 2 right here? Scale. Okay, so dilation with the scale factor of 2, so that's how I want you to read that. Okay, go ahead.
What are the coordinates of dilation to scale factor of 2 of the triangle PZG?
Scale factor of 2. So we're going to dilate triangle PZG by a scale factor of 2. I am going to write the coordinates of each point in PZG. So my coordinate P is over 2 down 1. My coordinate Z is -2 up 1. And G is over 0 down 2. To dilate it by a factor of 2, I am just going to multiply each of these coordinates by 2. So what is 2 times 2? Let's go fast. 2 times 2 is?
4.
-1 times 2 is?
Negative.
-2 times 2?
You have me going too fast.
1 times 2?
2.
0 times 2? -2 times 2?
-4.
Okay, so when you have a shape and you know the scale factor, all you have to do is multiply the coordinates by the scale factor. The new coordinates will be your new shape. So P is 4, -2. P prime. C prime is -4, +2. And G prime is over 0, down 4. Okay, your new shape, twice as big as your old one. Pause so you guys can draw. All right, Madeline, if you could read us the information about our two figures.
That's 9-5.
Oh, there we go. Okay, come on up and pull similarity transformation. Sorry, I went back to the trip backwards. 9-7 similarity transformation. Similarity transformation is the composition of a rigid motion, like a translation, or reflection, or rotation, with a dilation. We got triangle LMN. Let's go ahead and plot the LMN point. L is -4, 2. M is -3, -3. And N is -1, -1. We got a nice little triangle here. Pull out triangle. Suppose the triangle is translated 4 units to the right and 2 units up. So I'm going to put a T for translated. And we do the little brackets. And 4 units to the right is a 4, positive. 2 units up is a 2, positive. And then it's going to be dilated. So when we have a composition and we combine that with another, we combine our activities with a open circle. Kind of looks like a degree sign, but not up in the top right, but just in the middle. We're going to dilate it. We go big D is a dilated, and a scale factor is 0.5. And because we're doing it about the origin, we're not writing the comma O. All right, so let's go ahead and do the moving 4 over 4 and up 2. So our new M goes there. Our new N goes there. And our new L goes there. So I'm going to write the coordinates for L prime, M prime, and N prime. And then I'm going to times them by 0.5 to get my new shapes. Okay, so L prime is over 0 up 4. N prime is over 3 up 1. And M is over 1 down 1. By the way, you can find that by just adding 4 and 2 to each of these coordinates. I'm a visual learner, so I like to draw the picture. Okay, so we're going to multiply each one of these by 0.5. 0 times 0.5 is 0. 4 times 0.5 is 2. 1 times 0.5 is 0.5. And -1 times 0.5 is -0.5. 3 times 0.5 is 1.5. And 1 times 0.5 is 0.5. Are we physically capable of drawing a dot halfway between, say, like 1 and 2? Are we physically capable of doing that? Yeah, we can do it. We got this. We got this, guys. So I'm going to plot our new triangle. So at 0, 2 is the easiest one we have. So here's our L double prime. 0.5 comma negative 0.5, that's over half, down a half. That is our new M double prime. And then over 1.5, up 0.5. That is our N double prime. And let's connect the dots. And that's our new little guy. Little guy there. He's half as big. Half as big as his big brother. Okay, so we start with A, B, C, D. And we're going to end at M, N, H, P. So we know we're going to shrink it, right? So let's go ahead and, do we want to find, I'll let Clay decide. Clay, do you want to find our scale factor first? Or do we want to see about our reflection? Okay. So Clay, count the boxes for me. How many boxes are between C and D? 7. Do you guys agree with 7? And then Nancy, what about my little guy here between P and H? 3.5. Oh, boo! That's not going to do me. We can work with 3.5, right?
Yeah.
We could abort that mission and do A, B, and M, so those are also straight. But if we're okay with 3.5, we can work with it. So how do I go? What do I multiply 7 by to get 3.5? Yeah, so our scale factor is 1/2 because it's the new over the old. Okay, so here's something to think about, Jade. We've got, so I have to match A and D. Which side does it match up with on our little guy? Jaden. MP. But wait a minute. That is over here. So we're going to have to reflect. And what's the heavy line in between our two trapezoids, Shelby? Yeah, the y-axis. When we reflect across the y-axis, our y's stay the same and our x's change signs. So we're going to go, A, B, C, D, and then we're going to reflect across the y-axis to get A prime, B prime, C prime, and D prime. And we're going to shrink that bad boy, and hopefully we end up in the same spot. Okay, so D was -8, -2. My new D is going to be the opposite X value and the same Y value. Because you're just bringing it across. So it's going to go right here. Okay. My new C is at -1, -2, and it's going to reflect across the y-axis, so the x is going to become 1. Hold on. -1, -2. I'm writing it on the graph, and then it's translation. So my new guy is going to be at 1, -2, or right here. So my new bottom of my trapezoid is right here. Okay. A was at -6, 2. And the new guy will be at 6, 2. This is new A. And then B was at -2, 2. And his new guy is going to be at 2, 2. Okay, so my new shape. Boom, 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 boom. Why are you letting me do this? I wrote the dilations in the wrong spot. Just gonna go ahead and erase them. You don't have to erase them. I'm gonna erase them.
Just start over.
I'm gonna erase mine. We preserved the distance reflected across the y-axis. Now we've got to shrink it down. So we're going to take our A prime, B prime, C prime, and D prime coordinates, and we're going to multiply them all by 0.5. And then when we do that, we should get M, N, H, and P. Okay, so A prime, B prime is 6, 2. We multiply those things by 2, by 1/2, and we get 3, 1. Is M at 3, 1? Check it out. Is it at over 3 up 1? Look at your paper. It's on your paper. So pre-drawn. So B prime is over 2 up 2. We want to shrink those down by 1/2, so that's 1, 1. Is N at 1, 1? Yeah. C prime is at over 1 down 2. We're going to cut each one of those in half. Is H at 0.5, -1? -1. Okay. And then last check, D is at 8, -2. P would be half of those, which is 4, -1. Is P at 4, -1? All right. So we know that, let's put it all together, that we have a, we reflected it first, so let's put it on the inside. A reflection across the y-axis of trapezoid A, B, C, D. And we did in composition with a dilation of 0.5. And that it equals M and H. Super fast. Okay, we need to find if there's a similarity transformation. This is our learning objective for this chapter. So we're going to compare the sides of our two triangles. The first side we're going to compare is JK and RS. JK and RS. Give me a thumbs up when you have that written down. So JK over RS. So let's go ahead and write the numbers. JK is 10. RS is 12. I got these from the triangle congruence or similarity statement. This reduces to 5, 6. I know some of you guys forgot to reduce on that doggone chapter test when we were doing trig ratios. Please go ahead and reduce things down. So then I want to look at KL and ST. If these two triangles are similar, this KL over ST should also be 5, 6. KL is 12 and ST is 16. When I reduce 12 over 16, 4 goes into both of those things. So 4 goes into 12 3 times. 4 goes into 16 4 times.
No.
Is 5, 6 equal to 3/4? No. So these are not equal. And no similarity. Transformation.
Yeah.
Are these lightning bolts the same dimension? Like, is one longer? Like from here to here? Is there any angles that are not preserved from one to the other? So is this the angle the same as this angle? Is this whole angle the same as this angle? Are all our angles preserved from one shape to the next?
No.
Which angle is different from one shape to the next? All angles the same. So we can say that these are similar, and that to get from our, we'll go from little guy to the big guy. So to get from our little guy to the big guy, we have to move him over. So we've got a translation and a dilation. Okay. Now look at smiley face. Is one smiley face more oblong than the other? Or is it circle and then circle?
Looks like circle.
Well, look at your paper. You can get a closer look at your paper. So, are they the same? So, circles are all similar to each other. So, if we're confident in saying that these are circles, then it's similar.
One's facing.
The small one's like smush.
Right? So, if something is facing to the side, how do I go from facing upright
Rotation.
to facing to the side? It's a rotation. So, this is similar. We rotate it. So we have to rotate this guy. After we rotate him, we're going to have to move him. What's it called when we move? Translation. And then we have to shrink it. What's it called when we shrink it? Dilation. Nice. Don't put anything away. You guys are going to practice for 9 minutes. Let's have a 9-minute practice. When the timer goes off, you guys can pack up. If you pack up before the timer goes off, you'll lose points on the assignment.
Because you're really neat.
There you go.
So what's it looks like you're really neat.
It's not out that way.
What happened? You need a bunch of pregnancy things. You sure?
We don't Okay, guys, once the timer goes off, you guys are more than welcome to pack up and get ready to leave. Until then, do not do so.
Nice.
I guess what they're yours.
Okay.
And then it's definitely yours. Draw it. No, here,
Then that's what I big invert.
So you guys can definitely do the first 4, if not 6 problems.
That's cute. Number 1 is an enlargement.
Have you read the instructions yet?
Because a solid figure is a dilation of the original figure, which is that large. So it's an enlargement.
This one is no, it's not.
Yes, because the dotted figure is original. And the solid figure is. Oh, so
Yeah, this is another one.
No, we have to talk about the scale factor. What? Yeah. How do we do that?
It's just the new over the old.
Oh, that's right.
Yeah, new over the old. Wait.
I thought, yeah, no, yeah. Scale.
Wait, so it's
New
two?
old is up there.
So,
So 3 over 5.
Yeah, Adam.
That would be 5 over 3 because 3 plus 2 equals.
No, because the new. Oh, yeah. Sorry. Yeah, 5 over 3. Okay. 5 over 3.
you guys, number 1 is not 2/3 for a scale factor. If you put 2/3, erase it right now.
It's 5 over 3.
The 3 is right, the 2 is not.
Oh my god. I don't think that's just divided.
Yes.
I think we can keep it as a fraction.
I think we need to put that.
Although, to go from the dash.
I'm gonna put solid or we get solid. This is a reduction, yes? The C's.
Dash.
So isn't it gonna be a 4 over 8?
So then it's 8 over, no, 15 over 8. Right, Danny? Number 2 is 4 over 8. I hate over 8. Because it's the original. It's the
I got
new.
reduction and the scale factor is minus 5.
Wait, you're supposed to solve it out? I think it's
No, but since this one, you can simplify the fraction to 4 over 8, which.
Well, it's just equals to a 4, which equals, yeah.
Yeah.
4 over 8, which equals to 4.
Yeah.
I guess the same fractions.
Is it a dotted line? Is that
Enlargement.
before?
And enlarge this from 9 to 16. So then 16 out of 9, which is 16. So 3.
Count the box.
Because everything is 16 over 5.
The one that we read.
I thought.
I gotta take a little bit.
Okay, so it's 4 over 10 and
Right? The original is the dotted line, so yeah. So then it's the old, which is 14.
Yeah.
Okay, so then 4 over 1.
Oh, yeah.
You have to leave it as a fraction.
Don't make me look up.
You can just
Yeah,
put it
yeah,
as regular.
Is it this in the one or 2? I think.
Oh, wait, I can't even see this. Okay. Yeah, because the dotted line is the original. So, yeah. So let's do, I'm doing, this is the 2, this is 1, 2, 4. So that's 4. Yeah, over 1.
This is
This is an
Side air from the southwest class.
we got to number 6.
If you guys would like to stay in and get help turning in your test corrections. I'll be in at break.